Okay, welcome back to NeetCode Day 10, and today we're looking at a two-pointers problem, which is the two integers sum 2 problem. And the problem states that given an array of integers numbers that is sorted in non-decreasing order, return the indices one index of two numbers, index 1, index 2, such that they add up to a given target number targets, and index 1 is less than index 2. Note that index 1 and index 2 cannot be equal, therefore you may not use the same element twice. There will always be exactly one valid solution. Your solution must use one additional space. That means we cannot initialize any arrays, hash maps, sets, or anything like that. Okay, so there's a lot of very good information here that we can use to solve this problem. First off being that the array is sorted in non-decreasing order. And that means it's sorted from least to greatest, which is great for us because then we can make a two-pointer solution based on that knowledge. We also get that return the indices that are one index of two numbers, meaning since the solution here is 1 and 2, that makes target 3. We don't actually return the values at those indices, even though that's what it looks like. We're actually returning the one indexed version of their indices. So this would originally be 0, and this would originally be 1. But every time we return an index, we want to add 1 to it. So we would say this is 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1. That's how you get it in one index form. You just basically translate it to one index by just adding 1 to the actual index. Okay, and there at least has to be exactly one solution, meaning that whatever we return within a while loop, we don't have to return after the while loop because if it includes the actual answer, which is great. All right, so let's move on to the implementation, right? So let's say we have the two pointers. We want one pointer being at the front of the array and one at the end, right? That's just the way things go in two-pointer solutions sometimes, most times. And we can do that by doing len numbers minus 1 and I as equal to 0. And we don't want the indices to be the same because index 1 and index 2 cannot be equal to create target, right? So we have to do while I is less than j. Okay. Now, while I is less than j, we need to check something all the time. Every time we recurse, we need to check this one condition. What is that one condition? We need to check whether the sum of these two values equals target. So to do that, we can create a sum of num, integer value, that does numbers at I plus numbers at j. That's just a sum, right? And we need to check whether this equals target. So if sum of num equals target, return, now we return the list, right? Because we're returning a list of int here. So we need to return the one indexed indices. So this would return the 0 indexed indices, but we need to do one index, which is just adding 1 to it like I explained before. Okay. Now this is not the only thing. We need to actually increment and decrement two values here because we want to get to a solution. If this is all we do, this would be an infinite while loop, which is not what we want. We also know that since this always guarantees an answer, this will always return something, so we don't have to return something outside of it, right? But to guarantee an answer, we need to increment and decrement I and j, right? So to do that, we need to use the fact that this is a non-decreasing order. So let's say if sum of num is less than target. If sum of num is less than target, what pointer do we have to move? So let's say if target equals, let's say target here equals 6, right? Now, the first index is 1, value 1, and the last index is value 4. Target here would, the sum of num would equal 5, but 5 is less than target. We know the maximum value we have is 4. Why would we want to change that? We want to change the value of the lowest value and increment it up because you want to find the next biggest value to make it the target, if that makes sense. And the same thing goes for the other way. If we have sum of num is greater than target, then we know this number is too big, so we need to decrement it so that we have a value that isn't too big and can get to the target. So that's what we need to do. So if sum of num is less than target, we know we need to increment this value to get a bigger value. So this pointer to get a bigger value. And to do that, we can do I plus equals 1. And if sum of num is greater than target, we do j minus equals 1. Right? So that should run and work. And this should work all in on time. There we go. It does work. And it is in on time. And so let me just explain this more clearly because I feel like this is something I didn't understand. The reason this works is because it is sorted. Don't get me wrong. This is not going to work on a non-sorted array. If this was a non-sorted array, we'd have to sort this first and then run the two-pointer algorithm, which would then be O(n) log n because the fastest time complexity you can ever get in a comparable sorting algorithm is O(n) log n. Okay, so if it wasn't sorted, that would be the best time complexity. But here, it is already given to us sorted. And as a result of that, we have an ability to pick and choose which pointers we want to increment. So for example, if the target is a large number, and we already have the largest number and we still haven't met to the target, that means I needs to increment up. The I pointer needs to increment up. But if we have a target that's lower than the two numbers, than the sum, then we know we have a number too big and we have to decrement it to get to target. And that's basically the actual thinking behind this. And that's how we get to an O(n) time complexity because we're not iterating through the whole array, but we're iterating it through it once because we're only checking a condition and iterating one value each time. If we don't get a solution. So yeah, that's how it works, and I hope this made sense. And if you have any questions, please put them down in the comments below, and I'll try to get back to you guys. Thanks for watching. See you guys for day 11.